Welcome to the Explainer. Today, we're diving into something really exciting that's just hit the open source AI scene, the Rnj-1 model from Essential AI. This thing is making some serious waves, and we're going to break down exactly what it is and, more importantly, why you should care.
All right, let's get right into it. So Rnj-1 is an 8 billion parameter model, and that name, it's a pretty cool nod to the legendary mathematician Ramanujan. But the key phrase here is instrument of intelligence. The whole idea is to create a powerful, open tool that can hang with the absolute best models out there.
So, talk is cheap, right? How does this thing actually perform when you put it to the test? Well, the team at Essential AI put Rnj-1 through its paces across 3 really crucial areas to see how it stacks up against the competition. Let's check out the results.
First up, and honestly, this is a massive deal, Rnj-1 is an absolute beast when it comes to writing code. We're not just talking about spitting out a few lines of Python. It's built to act like a real software engineering partner, to understand and actually do complex, real-world work. Now, have a look at these numbers. Rnj-1, remember, is an 8 billion parameter model, but look where it lands on these charts. It's not just competing with, it's sometimes even beating models that are more than double its size. That performance-to-size ratio is the real game changer here. It means you get world-class results without needing a supercomputer to run it. And this quote right here just nails it. The SWE bench is all about practical, everyday software tasks, like fixing actual bugs from a GitHub project. Being an order of magnitude stronger isn't just a little bit better. No, that's a gigantic leap forward in terms of being genuinely useful in the real world. And it doesn't stop there. It's also a champ at using external tools. You can see it just blows past similar models on the Berkeley function calling leaderboard. And get this, it can even use a profiler to analyze its own code and then make it more efficient. That's like a programmer who can write amazing code and then also optimize it to run faster. It's pretty incredible. So all this amazing skill with code, it usually points to something deeper, right? Like a real knack for abstract reasoning. So the next logical question is, how does it handle other tough subjects, like math and science? Well, the numbers really speak for themselves. We're talking about advanced high school math problems that stump even the brightest kids, and graduate-level science questions that are a challenge for human experts. And Rnj-1 is right there, shoulder to shoulder with the top open models. It is a serious contender in STEM. Okay, for anyone who actually wants to use this model, this is the slide for you. Performance is everything. And what this chart shows is that you can actually shrink the model down to make it run way, way faster. I mean, look at that throughput jump. And you don't lose its power. That makes it so much more practical and accessible for developers everywhere. So, a model this good doesn't just pop into existence overnight. So how in the world did the team at Essential AI pull this off? It turns out their whole journey was built on a really specific and pretty bold philosophy. They made a huge bet. See, while a lot of the focus in AI has been on fine-tuning with reinforcement learning, Essential AI went all in on the pre-training phase. Their belief was that true, deep intelligence comes from getting the foundation right, from compressing massive amounts of data in the most effective way possible before you start teaching it specific tricks. And this whole philosophy was guided by 4 really clear goals. This wasn't just some random project. They wanted to prove their research was on the right track, set a new bar for how this work is done, build a tool that was so good they'd actually use it themselves, and of course, give something truly valuable back to the open source community. So they planned out their year super carefully, breaking it into 2 major phases. At the end of each phase, they did a massive training run. This let them test their best ideas at scale, learn from what worked, and then build on that success for the next round. It was a really smart, iterative process. And all that careful work, it paid off, big time. They came up with some major research breakthroughs, like new ways to mix data to make the model better at science and math, and figuring out how to teach the model to think about how code actually runs and changes over time. We're not talking about small tweaks here. These are fundamental improvements. So, Rnj-1 is launched. It's a huge success. What's next? Well, this isn't the finish line, not even close. For this team, it's really just the starting point for what comes next in open intelligence. They're already looking ahead at some really fascinating new ideas. Just imagine models that can process way more information at once, like a whole book or an entire code base. Or models that are even more efficient to train. They're dead set on pushing the boundaries of what these instruments of intelligence are capable of. The team's whole vision is just captured perfectly in this quote from the computer science pioneer Alan Perlis. It's not just about building tools, it's about the joy of creating, of exploring what's possible, and ultimately about putting real intelligence into the hands of everyone.
And that really leaves us with the big question, doesn't it? Rnj-1 is a huge win for the open source world. So is this the way forward? Is this open, collaborative path built on fundamental research the thing that's going to truly change how we build the future with AI? It's an exciting thought.